So I have given you in the folder for the workshop, I have given you a data file, data SEM, right? So this is the data, okay? And I have also given you the description of the survey. Okay, so we have three major constructs that we are going to work with. One is called as the leadership scale. It has 10 items, okay, and it has three dimensions. So empowering dimension, task orientation, 4 items, and leading by example, 3 items. Then we have a justice construct, has 5 items, and we have the creative performance behavior construct, which has 6 items. So what we are going to do now, and we have this data, and along with this, we have these demographics, and I have also given you averages of the overall averages of these items. So this is basically an average of all the items of this respondent, then PJ, and then so on. So let us start working on SPSS. So this is, if you launch SPSS, this is how the window will look like. And our first step is to import the data. So we want to load the data for our working. So we'll go to this, and then we'll look at the data, and we'll look at Excel. Actually, it is CSV. So let me use data sam.csv. Okay, so I will click open, and it will open like this. So it will say, does your text file match a predefined format? So let it remain at no. How are your variables arranged? So they are delimited by a comma because it is a comma separated version. Are variable names included at the top of your file? Yes. The first row includes the names of the variables, so it should be yes. Next, okay, the first case, so this is correct. How are your cases represented? Each line represents a case. How many cases do you want to import? All of the cases. Next, which delimiters appear between variables? So comma and space, this is by default. So next, variable names, this is okay, so leave it as default. Okay, so just press the okay. So I need to close my CSV file, otherwise it will not load. So I will do the same thing again. Next, yes, next, 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 and finish. Okay, so now my data has been loaded. Okay, and I have my variables emp123, to123, lex123, ej125, igen1234, 123, mobs123. This is this, and then this one. I'm not sure what are the last 3 rows, last 3 columns being shown here. This one is correct. Education data is, so I will just copy this column. If you're getting this problem, as I see that the last four columns, so I'll just copy all four of these values, okay, and then we'll just paste it here, okay. So now our data is fine, and I will clear these three columns. So now we have the demographics and these variables, and I will save this as SAV file. So I will save this as data SEM. I will save this. All right, so the data is now read, okay, and we have our variables, okay. We can go to the variable view and check their type is correct. They are all numeric, okay. This one is okay, decimal. I can change this to decimal, change this to 2 decimal, the average, okay, and yeah, so that is fine. 3 again, and then labels, values missing, columns. We can make all these as size 8. They are all right aligned, so I can make them center aligned. Values, okay, and then you can copy these values and paste it. These are all scale, so we'll declare them as scale variables, though they are Likert, and should use Likert data is usually an ordinal data, but even declaring them as scale is okay, fine. So we'll declare them as scale data. Okay, and I will save this. So this is my data variable view, which is okay, set. And so now my variables are all, data is center aligned. Okay, I have declared their values. Everything is done. Now the first step that I want to show is, let us go and look at the reliability part. So you will see reliability in analyze, scale, and reliability analysis. Okay, so this is a window that will open up for you. You can shorten it as you like. Okay, and we want to test the reliability dimension wise. Reliability should always be tested dimension wise. So there are three dimensions in this case: EMP, that is empowering, task orientation, and leading by example. Now there are, go to statistics. We'll go to statistics and we'll say descriptives for items. Okay, okay, scale, and scale if item deleted, right? Summaries if you like, mean, you can also report inter-item correlation. Okay, continue. And you can also give a title, empowering behavior, doesn't matter. And now what I want to demonstrate here is you will see there is a paste option. So the moment you click on paste, you will see that a syntax editor like this opens up. Now, all of us, we believe that we feel that SPSS is actually a graphical GUI based software, but I want to demonstrate one very important quality of SPSS that you should keep in mind is the idea of a syntax file. Now you see what happens is when you will be working on your data, your PhD data or your uh, sort of any research data that you have, you will you will click on some buttons in the SPSS on a particular day and you will get the results. But later on, you will not remember what uh, what buttons you clicked, what options you had taken in order to get the result that you had done. So this syntax file really helps at that time. You can make comments, you can say reliability test for empowering behavior done on July 22, 2021, and you can close the comment. So you can add comments and you can save it. Okay, so you can, wherever you are working, okay, whatever is your data folder, you can simply save it as. Okay, and then what you do is you just simply click on the sort of copy this, and you would see there is a button here, run selection, and you run this, and the moment you run it, you will get the same kind of output that you would have got when you would have done it using this. Now the beauty of this is you can save this file, and next time you will not have to go and figure out and try to remember what options were you clicking at that time. A lot of times we say that भाई उस दिन तो चल रहा था analysis, आज क्या हो गया, I don't know, why is this analysis not running, so on. So this is something that you should, I strongly recommend that you should follow. Okay, keep pasting your syntax in the script. Okay, so let us look at the output. The valid cases are 557, no excluded case. The Cronbach's alpha is 0.856. On standardized items, what does this standardized item means? It means that this was basically done using the inter-item correlation table. This one, the left side output was done using the covariance table, variance covariance formula that I had shown. What is the item statistic? The mean of the items, the standard deviation, the number, then inter-item correlation matrix. So you have these three correlations. If you take the R bar, it will be 0.68, okay, plus 0.59 plus 0.722. Okay, so we can do it here. Let us try to do what is our R bar. R bar is equal to, it is 0.68 plus 0.59 plus 0.722. Okay, whole divided by 3. Okay, so K is equal to 3 for us. So what is alpha? Alpha is equal to K times R bar, sorry, K times R bar whole divided by 1 plus K minus 1, that is 2 times R bar, okay, which is 0.856. And this is exactly what the software has reported, 0.856. Okay, so you see, this is exactly what the software is doing, the formula that we have been working on. Then there is this important table, item to total statistics. So you have the scale mean, okay, if items deleted. What is more important is you should look for item to total correlation. And it shows that each item is actually showing very good correlation with the total, that is the sum of these items, which is an indicator that all the items are actually good items of our scale. If there was any item to total correlation that was low, that was small, then you should have considered dropping that particular item. And Cronbach's alpha, if this particular item was deleted. So if I were to drop EMP1 from this set of items, my reliability will reduce from 0.856 to 0.839. Similarly, EMP2, if I were to drop, it will reduce to 0.743. And if I drop EMP3, it will reduce to 0.810, which shows that all these items are actually good items and I should not drop them from my item set. These are good indicators of my items, right? So this is what we should be doing. Similarly, now it is very easy. You can test the reliability of other set of items. So the other dimension is TO1234. This is task orientation, okay, and this will remain the same. So I will paste it in my syntax file. I go to my syntax file, I see this second command pasted. So I will copy it here. I will copy it and I will paste it. Okay, so this is reliability test for task orientation behavior, and I can simply select this and run the analysis. So the alpha is 0.903. This is the inter-item correlation. You can do the same thing that we have done. All the item to total correlations are excellent, very good. And the Cronbach's alpha, if item deleted, there is no item that if deleted will actually improve our reliability. That means all 4 items must be retained in the right. And this is for the overall sum of 4 items. What is the mean? What is the variance? What is the standard deviation? And what is the number of factors that are right. So as a homework for tonight, okay, as an assignment, what you should do is create your syntax file and you should do the reliability test for LEX 123, then PJ 125, and then IJ 123 and MOBS 123. Okay, so you should do reliability analysis and write it, report it in your create add to your SPSS syntax